Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our second lesson on logic. In the last lesson, we learned about the nature of a statement, the fundamental logical connectives, and truth tables. Today, we will learn about compound statements. We will construct truth tables for statements that are connected by logical connectives, and we will describe their properties and laws. If you are ready, we will get started. A statement formed by joining two or more statements by a connective or multiple connectives is called a compound statement. As an example of this, consider each of these statements. 10 is a multiple of 5. Ibex can breathe underwater. The digits of a multiple of 9 add up to a multiple of 9. Pi is a whole number. First, determine the truth value for each statement. Then, determine the truth value of each of the following compound statements. If you like, you may work in pairs to complete this exercise. Go ahead now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. This was an interesting exercise, was it not? The first thing we must do is to determine the truth value of each initial statement. The truth value of statement P is true. The truth value of statement Q is false. Ibex cannot breathe underwater. The truth value of statement R is true. And the truth value of statement S is false. Now we are ready to find the truth value of each compound statement. P and Q equals true and false, which is equivalent to false. R or S is equivalent to true or false, which is equivalent to true. So the statement, if P and Q implies R or S, is equivalent to the statement, if false, then true. So the truth value of the statement is true. Not P and Q is equivalent to saying not true and false, which has the truth value false. So the statement, negation of P and Q implies R or S, is equivalent to the statement, if false, then true. Now, for the third statement, R or S and P and not Q. The statement, R or S, is equivalent to saying true or false, which is equivalent to true. The statement P and not Q is equivalent to true and true, which is equivalent to true. Therefore, R or S and P and not Q is equivalent to true and true, which is equivalent to true. Do you understand, students? It is all a matter of what statements we hold to be true or false and how they interact with each other. Now let us take a few minutes to practice the construction of truth tables. We will take P and Q to be any two propositions. We will make a truth table for this compound proposition. If P then Q, not P or Q. Our table must have 4 rows to account for all possible combinations of truth value. It must also have 5 columns, 1 for each statement and 1 for each connective. In the first column, we put true in the first 2 rows and false in the last 2. In the second column, we put true in the first and third row and false in the second and fourth row. You see, in this way, we account for each possible truth value as well as each combination of the two. Not P, by definition, must have the opposite truth value as P. Therefore, in its column we enter false, false, true, true. The last two columns are a bit more complicated. If P is true and Q is true, then each compound statement has truth value true. This also applies if only Q is true, or if both P and Q are false. Do you understand? The only situation in which both the compound statements have a truth value of F is if P is true, but Q is false. In this way, we have constructed our truth table. Now it is time for you to try, students. Construct a truth table for these statements. Do your best, and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, students. Did you have any trouble? I hope not too much. Let us compare our truth tables. Unlike the last table, this one must have 6 columns. 1 for each statement, 1 for each connective, and 1 at the end for the compound statement. Does yours look like this? If so, you have done a great job. After the lesson, teacher, please review the truth tables and help the students with any trouble they might be having. Each of the logical connectives has properties which will help us to understand how they interact. Conjunction and disjunction, for example, are commutative. This means that in the case of conjunction for any propositions P and Q, we find that P and Q is equivalent to Q and P. In other words, the compound statement has the same meaning regardless of the order of the propositions. Conjunction and disjunction have other properties as well. They are associative. This means for conjunction that for propositions P, Q, and R, the statement P and Q and R is equivalent to the statement P and Q and R. The placement of the brackets makes no difference as to the meaning of the statements. Conjunction is distributive over disjunction, and disjunction is distributive over conjunction. Therefore, the statement P or Q and R is equivalent to the statement P and R or Q and R. This is true of disjunction as well. The statement P and Q or R is equivalent to P or R and Q or R. Make a note of these properties, students. Knowing them will be very useful in the next lesson. Today we have learned about compound statements and practiced making truth tables. We have also learned that conjunction and disjunction are commutative, associative, and distributive over each other. Until next lesson, thank you, teacher. Thank you, students.